Everybody. So today we are going to be talking about the trigonometric ratios in a right triangle. So now that sounds pretty fancy, but once we take a look at it, you're going to be like, all right, I remember that. So take a look at this right triangle over here, triangle ABC. You have the right angle at B, and you have two other angles at A and C, and you have three sides here. Now if you remember, we spoke about the three sides of a triangle. One of the most important ones is the one opposite the right angle. Do you remember what we called this side of the right triangle? Hopefully some of you guys are saying it's called the hypotenuse. So I'm just going to label it hype for hypotenuse. Then the other two sides, if you remember, were called legs. But now I'm asking you to use two different words that we are going to use when we do these trigonometric ratios. So I want you to label the side opposite angle A, so opposite it. I want you to label it op for opposite. And the one right next to it, that's not the hypotenuse, the adjacent, because adjacent means next to. So knowing that much, you should be able to easily complete or understand how to use these trigonometric ratios. So let me just remind you what a trigonometric ratio is. We have sine, we have cosine, and we have tangent. So those are three trigonometric ratios. Now, if I want to write the equation, it's always going to be sine of the angle. So sometimes they write theta. So that symbol theta looks like this. That's sometimes what they put in here. But sine of the angle is equal to the opposite side over the hypotenuse. Cosine of the angle, or cos, is equal to the adjacent side over the hypotenuse. And tangent, or tan, of the angle is equal to the opposite over the adjacent. So these are the three trigonometric ratios. Some of you remember it or have learned it as SOH, CAH, TOA. That's a nice way to remember. And I like to write it like this. SOH, CAH, TOA, where it's SOH, CAH, and TOA. So you can remember these three ratios. If you write it every time you're doing a problem, there's no way that you can go wrong. Now, there's only three different ways that you can use SOH, CAH, TOA. Not because there's three different ratios, but if x is the angle, there's one way to solve it. If x is the numerator, there's a different method or way. And if x is the denominator, there's a different way as well. Not that they're three very different ways, it's just really the only three ways that you'll get using SOH, CAH, TOA. So let's try some practice problems. So if you look here, starting with A. So how do we diagnose which trigonometric ratio we're going to use here? The first thing I'm going to do is label the hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle. So here's my hypotenuse. Then, based on the other angle they give us, so not the 90-degree angle, but based on this angle, which they call a reference angle. Based off of the reference angle, the next side that you want to label is the opposite, and the last side the adjacent. And then maybe up top you want to write for yourself, hold on, I gotta just make the pen a little bit thinner so I can fit it. SOH, CAH, TOA. Now, how do I know which one I need to use? Now, if we pay attention here, we have the hypotenuse, and we're looking for the opposite. So which one has H and O in its, is it SOH, CAH, or TOA? Or you could tell yourself, hey, we're not using the adjacent, so anything that has an A is not going to work. So really, we have to use sine here. That's how I know which one I'm going to use here. Now, the equation, sine of the angle equals the opposite over the hypotenuse. Look how easily I can set that up. Now I have to solve. So once you could set it up, the easy part is solving, but I'll show you the different ways that you could solve. So here, x is in the numerator. This is one way in which you will find that you have to complete these problems. When that happens, you could just put this over 1 and then cross multiply. Here, let me just use a different color. So when I cross multiply, 1 times x is x. And then when I cross multiply here, I get 23 times sine 33. Now a very key part here, if you're going to put this in your calculator, you have to make sure your calculator, the calculator is in degree mode. So click on the word mode, because we are dealing with 33 degrees. So click on mode and make sure if you go, I think it's 3 down, you'll see radian and degree. Make sure it's blinking over degree and click enter. So now when I put this in the calculator, 23 times sine 33, I get 12.52669781. Now it says here, round all your final answers 2 decimal places. So if I go 2 decimal places, this is 12.53 centimeters. So that's really how you complete this problem. Let me see if I can show you the 2 other kinds of ways you would see this. So let's look at B and C. So starting with B, I'm going to start the same way. In fact, I'm going to use the same color so you could see everything work out the same. First thing I want to label is the hypotenuse. So here's my hypotenuse. Then here's the angle they're labeling for us. Notice they didn't give it to us. Here's the opposite. And here's the adjacent. So I'm going to just really pick out here what I have. And then I need to write so maybe I'll just copy this so I don't need to write it every time. So look at this. I don't need the hypotenuse. So this doesn't have, this has it, this has it. Oh, this is opposite and adjacent. So it looks like we're going to be using tan here. So tangent of the angle, which is that theta symbol I mentioned, equals opposite over adjacent. Now for this problem, it's different. It's completely different. Now, if x was in the bottom, it's not completely different. You'll still be able to work with proportion, but here, our x, or our variable, is the angle. So in order to get the angle alone, we have to do something as called the inverse. So I have to do the inverse of tan, which is tan negative 1. So here's tan negative 1. So what happens is the inverse gets rid of tan, and I'm just left with theta. And then I have to do tan negative 1 of 34 over 16. And how do I get tan negative 1? If you look in the calculator, you have to, it's probably in blue, so you have to click second tan 34 over 16. And what I get is 64.79, 88765. So 2 decimal places would mean that this 64.80 degrees, because we found the angle. So that's the second kind of way that you can solve the problem. So here are variables in the numerator, and here our variable was the angle. And then let's see with letter C. So let me label everything. Again, I'm going to keep the colors the same. First thing I want to label is the hypotenuse. Then here's the angle they gave us, so opposite. And then this third one is the adjacent. And then I said I copied this so that I could just do copy and paste. I really pay attention to what I have here. I have the adjacent and I have the opposite. I don't need the hypotenuse. So if I don't need the hypotenuse, then I'm going to use tan again. So tan of 23 degrees equals the opposite over the adjacent. So here's the third way that you would have to solve. So notice x is in the denominator now. So there's a quick trick for this. Some teachers like to say, hey, this is the same thing. Put it over 1 and cross multiply, which you can do. Or you could just switch. You could always switch the ones that are being cross multiplied. So since x is going to be multiplied with tan 23, I could actually switch places. So this says x over 1 equals, oops, hold on, I pressed a button. So x over 1 equals 8, stays on top, but now instead of x, I write tan 23. So what happens when it switched places, I now know what x equals. X is by itself. So I get x equals, and now I have to do 8 divided by tan 23. And as I put that in the calculator, I get 18.84681,893. So now 2 decimal places means this is 18.85 centimeters. So really here are the 3 different ways. I know I didn't use cosine in these examples, but it's okay because really it's just a click of a button. The difference is clicking sine, cos, or tan in the calculator, or sine, cos, or tan inverse in the calculator. It's not so much a difference in how you solve it. So if x is in the numerator, you just cross multiply. If x is in the denominator, you just switch and divide. And if x, or your variable, is the angle, you use the inverse. Those are the 3 different things you have to do. So I have a few more practice problems here on this page. So you can practice problems here for the rest of this page. I tried to stay consistent, kept the colors the same as we did with the practice problems we did. So I'm going to zoom in so you could take a look at a couple at a time. And if you have any questions, make sure you reach out to me. Notice that I started to stop show as much work. I at least show a couple steps. That's the most important part, is to be able to show the equation. Oops. Is to be able to show the equation, show what math you did to solve, and then give the answer. So that's really the main parts that you have to show when you're doing these kinds of problems. And the reason why that is because let's just say you accidentally chose the wrong trig ratio. At least you could show the work and get partial credit. Alright, so those are the trigonometric ratios and the ways in which you could solve for missing parts of a right triangle using SOH. If you have any questions, please make sure you message out to me. Have a great day, everybody.